Okay, so who am I? Why am I standing here in front of you and supposedly talking to you about NativeScript? Sorry, TypeScript. So I'm a systems architect, I'm a developer, and lately I've been a trainer. So I actually get up in front of crowds all the time, lots of engineering students with laptops in front of them doing exercises. Since we only have an hour and a half, we won't be doing as many exercises. I'm an agile engineer with a big background in extreme programming. I used to work at Pivotal Labs. I was a consultant at Google for many years, and Pivotal Labs is big on extreme programming, although they don't mention it as much. But they're one of the early, what I call agile engineering shops, where we do test-driven development or behavior-driven development and pairing, and we try to make sure we have continuous integration and things like that. So I'm sure a few of you are familiar with that. I actually can spend a lot of time on that subject alone, but that's not what I'm here to talk about. I started the Angular NYC meetup. I am wearing the Angular NativeScript shirt, which I know some of, see one other in the crowd, but a lot of you are wearing just the NativeScript shirt. Mine has the Angular shape on the outside there. So I started that meetup in 2012. It just celebrated its 5-year anniversary. So we focus on user experience for web and mobile, best practices for development and deployment, including agile, corporate training, which is why I do a lot of training, and we're full stack JavaScript, both front end and back end, with on the back end obviously things like Node.js and MongoDB, etc. So I usually at this point try and get a little bit of a sense of my audience. I asked you a question about what you're using in terms of your versions of JavaScript, but I wonder also if some of you aren't developers. What very often happens is designers come to these lectures and they want more information. So are any of you designers that are here to learn more? Oh, not really. How about managers who are like hoping to manage their developers, and so they want to get the inside track on this stuff? Are there any other types of industries, anything I might have missed? This would be a speak up if you want to say like you're not part of the normal crowd. Okay, cool. So if there's anything else you want me to know, now's the time. Otherwise, I'm moving on. Okay, great. Okay, so you guys already know what JavaScript, lightweight interpreted, object-oriented language, and I used to call it an object-based language because of the prototypes that JavaScript is based on. A lot of the other object-oriented languages are pure object-oriented in that you create a class and then you kind of instantiate instances of objects from that class. That's actually not how JavaScript works. It's kind of weird. You have a prototype and then you sort of link to the prototype, which has caused a lot of confusion from people trying to program JavaScript in an object-oriented fashion. But two of the things, I guess, that have made it a lot easier is ES6 with its new class syntax. That's really, and we're going to be focusing on that a little bit. And TypeScript, as a superset of ES6, really takes advantage of classes. So we're going to be talking about that. But once again, if you have these slides, these are links to various areas of documentation online. So please, get a copy of this, and you can search all these on your own if you want to. This is a great resource. JavaScript is not Java. When it first came out, I actually taught JavaScript and Java back in the 90s, and I had to explain that to a lot of people. And still to this day, I get emails where you can see they've truncated JavaScript to Java. However, the if statements, the for and while loops, the switch statements, the try-catch blocks are very similar. So if you're coming from another C, Java, C#, C++ language, you're pretty much going to know the syntax of JavaScript. And JavaScript is both procedural and object-oriented. As I mentioned, the object-oriented had been a fudge up until recently. The procedural part, though, one of the cool things about JavaScript is it is a function-first language, where function are full-class citizens, they say, where you can actually treat functions as variables, you can pass them, and in fact, that's required a lot for the single-threaded nature of JavaScript. Everything is done with callbacks, and if not callbacks these days, maybe promises, and if not promises, if you're working in the world of Angular, perhaps observables, if you're familiar with observables, and if not observables, now we have the new async await syntax that's coming down the pipeline. But the bottom line is you need to deal with things in a single-threaded manner, and that's actually not this talk either. So if any of that is interesting to you, you can do some Google searches on that as well. So I usually go through a lot of JavaScript basics, and like I said, I'm just going to skip over a lot of this for you guys. I'm going to be moving forward straight towards the ES6 stuff. Also, I'm a big fan of using WebStorm. I mention it because I personally love it as a tool. If anybody wants a 60-day trial, 30-day trials are available for free. If anybody wants a 60-day trial, because we teach it, they allow us to give them away. So feel free to email us, training@zen.digital, and we'd give you one. So I also like to give a lot of references for where you can look up information about JavaScript. Obviously, you guys are also interested in TypeScript. Microsoft's got the documentation for that. But since it's a superset of JavaScript, one of the best resources, in my opinion, is the Mozilla Dev Network. And in fact, this set of slides links a lot to the Mozilla Dev Network. They really, if you did a search for JavaScript string length or JavaScript array sort, probably one of the first two searches that Google will return is going to be the Mozilla Dev Network. The other one that would be very popular would be W3 Schools. They're falling a little bit out of step with the newer ES6 stuff, but basically those two references are the best references for reading up on JavaScript. Also, there are a lot of online development environments for actually trying out a little bit of JavaScript online. I mentioned here Plunker, CodePen, JS Fiddle. In particular, CodePen and CodePen has a TypeScript mode, so you can actually try your TypeScript live. I think there might be a read eval print loop for TypeScript as well, but I know that CodePen specifically has a TypeScript mode, so that's worthy of note. Otherwise, for just plain JavaScript, if you're using Chrome, which I prefer, you can always open up the console and type in a little bit of JavaScript there. So here, as I said, are links to all the various features that are in JavaScript that I am not going to go into detail. Instead, I am going to expand upon what I'm hoping you already know, but if anybody wants further information, like I said, I create this for people who don't necessarily have all that information on JavaScript. So I talk about how the comments are there, and the classic, I guess this is actually a good first point of reference for ES6 versus ES5. The variable declarations in JavaScript, I was going to say classically, but that's a bad word. Traditionally, we're using var. Var declares a variable and optionally initializes it to a value. But one of the weirdest things about JavaScript, or at least old JavaScript, was the scope of the variable. It was completely different than all these other programming languages like C, C++, C#, and Java. It declared at the function level. So if you declared a variable anywhere in a function, that variable would exist everywhere in the function. And this is completely different than almost every other programming language that's similar to JavaScript. So people started to sort of say, hey, if we're going to update JavaScript, we should change the scoping rules. And so in ES6 in 2015, they created a new keyword for declaring variables, the let keyword. In addition, they created the const keyword, which is for constants. And this allows you to declare your variables block scoped. That means your variables will only exist within the squiggly braces that they are defined in. This is the way all the other programming languages actually work. And we're going to actually have some examples of this in some future slides. And the only other thing I'll say at this point, and I'll probably repeat it, is that if you're given the choice of declaring variables with let versus const, try and prefer const first until you actually need to create a variable that requires modification. In fact, a good ESLint tool will actually statically analyze your code and say, hey, you never modify this variable. Why not just declare the variable as a constant? And then later on, your compilation tools will say, hey, you're not allowed to modify that variable if you try to modify it. And then you could look at your code and say, did I intend to modify this variable, or was that an accidental side effect that the compiler is now telling me and warning me that I shouldn't have done? So believe it or not, using const is actually preferable in most cases. We'll talk more about these last two later, as I mentioned. So I'll talk a bit about the special values, and like I said, this is review for some people, but JavaScript is different than those other languages, and the types and special values that exist are different. So for instance, and these are also the same for TypeScript. As I mentioned, TypeScript is a superset of ES6 and JavaScript, so everything I say here is true, and then towards the end I'll get into more specific things that TypeScript has. So undefined is the default value for a variable. Now, you might be familiar with other languages where null is the default value. And then one thing that's interesting is you do have null in the JavaScript language, but you have to explicitly assign something to the value null. It's not going to be assigned for you as it is in these other programming languages. So it's there for you to personally use as, hey, this object doesn't exist, I'm assigning it the value of null. But when you first initialize a variable, if you don't give it a value, then it will take on the value of undefined by default. This is true also of parameters on a function. If you pass 0 arguments to a function that expects argument values, those argument values will come in as undefined as well. So that's the default value. So null represents an intentional absence of an object value. There's also the special value of not a number. This is returned by various mathematical functions. So if you try to get the square root of -1, for instance, that'll be not a number. And then infinity is also a constant in JavaScript and TypeScript. There's also a negative infinity, and it behaves mathematically like infinity. So 1 divided by 0 would bring back the value of infinity. So variables and function hoisting. So I mentioned that var was really weird, but var still exists in TypeScript. So here's a strange rule about JavaScript. Because JavaScript has been around since the 90s, and because some websites out there are as old as, there are 20-year-old websites out there, and the browsers need to still be able to render those old websites. So the rule is, never update JavaScript in such a manner that it will break old websites. So they couldn't just say, hey, let's make var work as block scoped. That wouldn't have been allowed. That's why they had to create the let keyword. Because if they had redefined the way var worked, old websites would have broken. So it is still allowed to use the var keyword even in TypeScript, which is that superset. So these old features are available, although they're no longer recommended. And once again, I'm going to mention ESLint. ESLint stands for, and also TSLint for TypeScript. These are linting tools that will statically analyze your code and make recommendations. One of those recommendations will be, hey, don't use var. It's no longer considered popular to use. But I recommend highly use a linting tool. It will find errors for you. Also, one of those weird things about redefining features was the triple equal sign that's available inside of JavaScript versus other languages. Normally, if you want to check if two values are equal, you use a double equal sign. And in fact, the double equal sign was the way that JavaScript did it originally. But people felt that they didn't implement it properly. I can actually show quickly a demonstration of this. Maybe I'll bring up that. So here's a quick demo. So here's, hopefully that reads well. Maybe I can make it a little bigger. So if I set a variable x equal to the value 1, and I set y equal to the string 1, my question to you is, does x equal y? Now, some of you have been programming in JavaScript for a while. Should x equal y if one's a string and the other one's a number? So if I use the double equal sign, they will be equal, and it's true. That is why they created the triple equal sign, because the triple equal sign will check to see if the types are the same first. And if they are different types, then it will be false. Whereas the original double equal sign in JavaScript did this type conversion. People complained, and so JavaScript came up with this the triple equal sign, which most other languages don't have. So even in TypeScript, it is recommended that you use a triple equal sign. Once again, this is something a good linting tool will recommend. It'll catch when you use a double equal sign and say, hey, you should use triple equal, because then you'll get a more accurate response. So here, let's talk about hoisting if you were to happen to use var. Once again, not recommended, but it's historical, and you might be pulling in JavaScript code into your TypeScript, so you might need to know that. Notice that I declare x at the top there, and it makes perfect sense that x would be undefined because I've declared it. But I don't declare y until after I check if it's undefined, and yet it's still undefined and not an error. Normally, if you don't declare a variable and you try to do a test against it, you'd get an error. And the reason why is that this, if it was in a function, would hoist the declaration of y to the very top. So if you declare y anywhere in a function, it's considered to be declared throughout the whole function. Now, maybe the actual initialization won't take place until afterwards, but this declaration is hoisted to the top of the function. That was one of the weird things about var. If we don't use it, it won't be a problem. And so here, if we look again, here we're saying try to check if z is equal to undefined. We never declared z, so that will actually cause an error. And I could actually, whoops, I was going to say I could actually copy that and show you that there's, I hit escape. There we go. I could actually copy that and maybe go back here and show you that this, because I got a reference error, z is not defined. So that's typically what would happen if you don't define a variable. Whereas notice we don't get that error with y. It's actually true because it gets declared later in the same function. Let's see. Oh, and then for function declaration, and this was also something where when I first learned JavaScript, I was like, how come I'm able to use a function that I don't declare until later? And that's another thing that happens, that function declarations get hoisted as well. So you could declare a function at the bottom of a file and use it at the top. And this is still true in TypeScript. So here we see function foo being declared after its usage, but it works. I'm actually allowed to call foo before the function is declared. Very strange behavior in most other languages, normal behavior for JavaScript. So bar because function declarations get hoisted. However, if I try to use the fact that functions can be assigned to variables, and I instead create a function, the same type of function, but I assign it to baz here, I will get a type error if I try to use it beforehand, because baz is undefined. The variable declaration is hoisted, but the assignment doesn't happen until afterwards. Only the function keyword, when used before the name of foo, hoists the whole function declaration. So these are really interesting specifics of JavaScript that are still true in TypeScript. Data types, and I'll be going over these again when we talk about TypeScript, because in TypeScript we can actually declare variables to be of these specific types. But under the hood in JavaScript we have all these types. We have null, which is a core data type, not very often used, undefined as we know, and then we have Boolean, number, and string. So Boolean has literal values such as true and false. Number has literal values like 42 or 3.14159, and string can have literal values like, howdy or anything that would be in double quotes. And we get a certain amount of automatic conversion that happens. Notice this strange, the double equal sign actually spills over here. If you're not using the plus sign, it actually will automatically convert strings to numbers. So when I say the string 37 minus 7, the answer is 30. Yeah, but only when I use the plus sign does it consider, plus sign is considered the concatenate symbol. So here I'm saying 37 plus 7, I'm saying add it to the end of the string. And there are certain tricks that you need to know in order to prevent conversion, because this automatic conversion is happening for you. So it's really something you need to know, because otherwise you'll get, it's one of those gotchas in the language. So I've talked about it being, no, I haven't mentioned yet how it's dynamically typed. So basically, if you don't use TypeScript and you declare a variable, you can reassign it to another type. So here I have a number, variable type num equals 5. There's nothing to stop me later from saying num equals hello there or num equals true, because there is no default type in JavaScript. That's why we have TypeScript. And TypeScript will allow us to say, hey, this variable must be of a specific type. And once again, we're getting to that a little later. Data types are converted automatically as needed. So I can say num equals, now it's a string. The plus operators I've mentioned does concatenation. So I can say the answer is plus 42 and get the string response. The answer is 42. And I've already talked about those last two there. So for more information on JavaScript itself, I give a lot of links to resources, which I'm not going to go into, and more so. And then I usually say, okay, now that you know ES5, here's a little quiz, so feel free to take that on your own time. But now let's talk more about ES6 and ES 2015. So that was my intro that I usually expand for people who don't know as much about JavaScript. But hopefully I hit some key points there that are really strange that even you might not have known. Okay, so most of the ECMAScript 6 features are actually available in the browsers today. That's why earlier when I asked, are you using Babel or not, I saw some people say no, because there's nothing wrong with using a lot of ES6 features directly in the browser. It understands them. The only issue there is what if your users are using an older browser? Now, nowadays we have this concept of an evergreen browser. Have you heard that term before? So the concept is the browsers automatically update themselves. So if you have Chrome installed, it'll automatically update to version 60 or whatever version Chrome's at these days. And you don't even realize it. Sometimes you'll get a notice that says, you know, shut down your browser and restart and I'll update to the newer version. And I believe Firefox does that these days, you know, and Opera does that these days. In fact, the old days of, you know, oh, here's Internet Explorer 10, and that'll be the standard browser for 2 years before we come out with another browser, those days are long gone because now Microsoft themselves has Edge, and Edge itself is also doing the evergreen trick of updating itself regularly. So because of that, most people aren't running old browsers. They're running brand new, very recently updated browsers. But still, there's a few people, especially some of the Fortune 500 old banks or whatever, might be running like IE9 or something, which is crazy, but it happens. And in those cases, you're going to need to pre-compile your code to ES5. And so TypeScript can, anything you write in TypeScript or ES6 can actually be transpiled to ES5 to run in older browsers. So even though you're using the latest language, you can still target old browsers. Let me just show you, though, this compatibility table, which I always like to show. So here we're talking about ES6 features, and green represents that they've been implemented. And if you look over here at IE11, none of ES6 is implemented in IE11. But once you get to Edge 14, you can see practically all of it has been implemented. Here we're looking at Firefox browsers, and you can see maybe 52 didn't have a couple of features over here, but almost every recent Firefox browser has every ES6 feature. Here's Chrome, once again, every ES6 feature in Chrome. Safari, as of Safari 10, every ES6 feature is available. If we move over, you see as of Node 6.5, you have every ES6 feature, even on the back end in Node. So this is a really good reference for finding out what features are available. That being said, none of these platforms have TypeScript built into them. You will still need to transpile, or maybe compile is the TSC, the TypeScript compiler, they call it. You'll have to compile your TypeScript at a minimum to ES6, but you can also target ES5 for older browsers if you want. Okay. And then the final thing I'll say about this is one of the keywords that was created in ES6 was for importing modules. In fact, the keyword's named import. And it allows you to break up your code so that different classes are in different files, or different portions of your code are in different files. And this is great. This is the way most other languages are done. You know, Java has its import statement, C and C++, they all have the import statement. So the fact that they use the same import statement here allows a consistency. This really makes it a lot easier for somebody to come from another programming language and enter the TypeScript and JavaScript world. There's only one problem with this. Nobody's implemented it. Literally none of the browsers nor Node have implemented the import keyword. So the only way to use import is to use a tool such as Webpack, or to use a tool such as System.js, which actually analyzes the code for you and then bundles it up or compiles it in the browser in the case of System.js. So Webpack is very often used under the hood for things like the Angular CLI is using Webpack. And in fact, the Angular CLI is using TypeScript with Webpack. And so it uses the import keywords, and so that's a very common thing to do, but you need to actually have your system set up properly. You need to have some sort of good seed, at least, to start off with Webpack. And I actually have, maybe if you ask me, I'll give a link to a Webpack example. And we recently did a conference where somebody gave a great talk called Webpack is Not Magic to try and explain how Webpack works. But the bottom line is it follows all the imports, transpiles all the code, and then bundles it up together into a single file that can be downloaded into the browser. So that's another advantage. Because it's transpiled into a single file, you don't have to deal with the multiple requests to the server to download your source code, and that actually speeds things up as well. And it'll also compact your code as it goes. That's why it's called Webpack. Okay, so let's take a look at some examples of ES6 versus the old ES5. The first one, once again, being the var keyword. So on the left, we have a for loop using var. This is an old school for loop. where we say var I equals 0, and as long as I is less than 10, we will continue to increment I and console log out the value of I. And then the point I'm trying to make here is that after our for loop, and here I got one of these nice little laser pointers so I can actually point at it. So after our for loop is over, I is still accessible here. So I can actually log out I even after my for loop. And as a nerdy after question, what is the value of I after my for loop? Anyone? It's 10. Because when I is equal to 10, then this will fail. And so that's the value afterwards. So we'll console log out numbers 0 through 9, and then afterwards I will be 10. And so this will actually console log out after and 10. And I, of course, could do that in the browser, but given only an hour and a half, I'm going to keep moving forward. Let's talk about ES6, though. So now we have the let keyword. So the let keyword allows me to declare a variable that will only exist within the for loop. That means I is no longer accessible out after the for loop. And so if I try to console log out I get an error. Now that is typical of most other programming languages, but JavaScript's var was special, and now let gives it more of a traditional declaration that's block scoped. And then of course we have the constant, which I will admit doesn't make much sense here. Why would I declare a variable inside a for loop to be a constant? But my point is I will get an error after one iteration. The moment I try to increment I with an I++, it will fail because I is a constant. I am not allowed to increment it. So here is another special feature that's been added to ES6 and as a consequence is added to TypeScript. So you might already be programming in TypeScript and not have used this feature yet. We have what's known as a template literal. A template literal allows us to have a string that is multi-lined without having to concatenate things. We're actually able to put a return in that string, and it'll be memorized or recorded in the template literal. So here in the old world, I might have to use a single quote HTML, and then I use a \n to represent a new line. So I'm saying, hey, if I was to print this out, you should go to a new line. And then I might use the plus sign to concatenate it to another line with a new line, and concatenate it to another line with a new line, etc. Here, I can very simply just put the text I want as long as I open it with this special back quote character. That is not the same single quote there as here. Those are different variables, different characters. And so that's important to note. That's actually on the same key on your keyboard as the tilde. That's a back quote. So we open a back quote and we close. I think I'm low on battery, so I can't use my laser pointer anymore. If anybody's got a AAA battery, let me know. Thanks. That's a back quote there and a back quote there. And so once again, why did we use the back quote for this? Well, we couldn't use the single quote because it's already being used for another feature in the language. And you're not allowed to redefine how the language works so you don't break the old code. So they had to choose another character. And that by choosing the other character, they hopefully didn't break any of the old code. And so that's the logic there. So here, there's another feature that's available with template literals besides just the multi-line strings. We also have the ability to do what's known as interpolation. And that allows us to take a variable and insert it into the middle of a template literal. So here, in the old world, we might say the name is Brendan, and we'd say yo, then that would be a string that we close, and then we concatenate it with the variable name, and then we concatenate it with the exclamation mark in order to print out yo, comma, Brendan, which I actually don't have here as the output. But then right here we have the exact same output, but instead of doing it with the concatenation, I do it with interpolation. So this is very similar to the C shell or bash shell in Linux. That's kind of a similar syntax there where I actually use the $sign and an open squiggly brace. I put the variable name into my template literal, and it will insert the variable into replace it, interpolate it is the term, inside the variable. And I'll also get yo, comma, Brendan, exclamation mark. So template literals, very powerful, available in ES6 and TypeScript. Okay, another feature is default parameters. Default parameters did not exist previously, and so we used to use this trick typically. We'd say, we want to say if you didn't pass us an argument, that we want to have a default value. So here I have a function called multiply by, and multiply by takes a number and a multiplier. Now, That multiplier says what to multiply the initial number by. But if you did not pass me a multiplier, in other words, if multiplier is undefined, undefined is considered a falsy value in JavaScript. There's a number of falsy values. Null is considered false in an if statement. An empty string is considered false. 0 is considered false. So I take advantage of the fact that undefined is equivalent to false, and I say multiplier equals multiplier if it's true, but then I have this short circuit OR feature, which says that if the first value is falsy, then I will take on the second value. And so if multiplier is undefined, then it will default multiplier to 2. If multiplier is not undefined, then that will be the value. So, and then I return that. Now, that was a hack, if you will, in the old version of JavaScript. Now we actually have a actual syntax called the default parameter that allows us to say, hey, if you forgot to pass me a variable for multiplier, here is the default value. And you actually pass it on the function argument list. So that's another feature that's available now in TypeScript. And then we return num times multiplier. You notice that it's only one additional line in ES5 here, but imagine I have several arguments that all need default values. This will actually become much more brief or concise in the ES6 TypeScript version. So it's very useful. There is one problem with this version of the code. What if I said, so here, just both of these will output this. If I say multiply by 3, 4, both of these will return 12. If I say multiply by 5, both of these will return 10. However, what if I said multiply by 6, 0? What will be the answer? On the right, 6, 0? Right. So on the right, it'll be 0. Because on the right, it'll work. On the left, 0 is considered falsy, and therefore the multiplier will take on the 2 value. So actually, there is a bit of an error here in that specific case. So both of these will actually output different values in the situation where the multiplier is 0. Because here, this was just a hack. Here, this is actually, we'll check to see if it's undefined or not. Arrow functions are probably the #1 feature of ES6, and as a consequence, TypeScript that everybody's really excited about. They allowed for a very concise or brief declaration of your functions, but they do require you to kind of recognize that you're declaring a function. So in the old world, you always had the function keyword for declaring functions. So it became very easy. It was an extra, 8 characters you always had to type, and programmers are lazy, so they said, let's create a version that's much more concise. So here we have 2 equivalents. We have sum on the left, where we create a function that takes 2 numbers and returns those 2 numbers added together. That looks normal. It's been around for a long time. Now we have something that looks a little stranger. We're declaring the sum function as just a parameter list, and then this fat arrow, equals and then greater than, and then num1 plus num2. And these are equivalent in ES6. This actually will take 2 variables and return them added together. So the reason why it's returning this value is because as long as you do not put the squiggly braces on the right side, as long as they are not placed on the right side, whatever you see on the right side of an arrow function is the return value. The moment you put squiggly braces on the right side and have a block of code, then that function, that arrow function, will return either void or nothing or undefined, or you have to have a return function, you have to have the return keyword in that block of code. So until you have a block of code, you don't need a return keyword. The moment you add the squiggly braces in the block of code, you have to then explicitly put the return in the arrow function. So we avoid having to have a return statement as long as it's one single statement on the right. This also works for functions that take no arguments. We just put an empty argument, and then we use the arrow function. This will return Nicholas. Return Nicholas. Now, another really interesting feature of the arrow functions is they don't have a this context. So just to show of hands, one of the most difficult to understand features of JavaScript is the this context. Are people familiar with the this context from JavaScript? I see a spattering of hands. Now, usually this in object-oriented programming languages refer to this object, the one that I'm in. The weird thing about the this in JavaScript is you can actually assign or bind this. And so there's all these tricks that are used in ES5 where you have to bind to the proper this context. We try to avoid those in ES6 and TypeScript by using the arrow functions. Since the arrow functions don't have their own this context, they inherit the outer functional scopes this context, and that actually keeps them sort of central to the object that they're in. So you avoid having this bind to this that you'll see in older code. And this actually makes object-oriented programming much more legible. So if you're curious to know more about the this context, there's a great book called This and Object Prototypes that you can read if you don't get this. Yeah, it's the first time I got a laugh from that line. Thanks, guys. Okay, so let's talk about destructuring. Destructuring is a very powerful tool in ES6 and TypeScript. It allows us to quickly get at the variables we need, either inside of an object or inside of an array. So let me just keep my eye on the time because I can lose track really easily. And I have plenty of material. So our object here, so we're starting with objects. We'll talk about arrays in just a moment. So here we have an object that has three properties: type, name, and ID. And type and name are strings. ID is a variable, a number. So typically you might want to have a shorthand to get at object.type or object.name. If you have a long function, you're constantly referring to these variables, you'll want to create shorthands for them to create a local variable type equal to object.type and a local variable name equal to object.name, so that later on you can console log them out, and that's what they'll look like. Now that's such a common thing to do that they created a shorthand to do this. So the shorthand, you'll notice the weirdness of this syntax is you start to see squiggly braces on the left-hand side of an assignment operator, assignment where we have an equal sign. Typically, you will not see squiggly braces on the left-hand side of an assignment, but now you will for destructuring. This says we're going to go into whatever object is on the right and pull out the type property and assign a local variable type to equal that property. And we're going to do the same thing for name. So notice, once again, here's something that takes 2 lines, can be done in 1 line, and there's a new syntax for it.
Is it based on the name, or is it based on the first 2 objects?
Has nothing to do with position when you're dealing with, it's based on the name. Has nothing to do, because there is no position here. It's just a coincidence that type and name are written first. I could have written this object in any order. The property is the index into the object, the key, if you will, into the object. Yes?
Can you declare with let and then modify the variable, which then modify the context?
That's a good question. No, I believe it's like this. So it depends on whether or not the variable you're making a copy of locally is an object or an array itself. If it's an object or an array, then you're pulling in the variable by reference, because objects and arrays are referred to by reference. But if it's a number or a string, those will be copied over because numbers and strings are brought in by value. So it will depend on the type, whether or not you have a variable by value or by reference. But if it was an object, yes, that would be true, just by the very nature of JavaScript. The other thing you also can do is you can actually rename the local variable name, and I'm going to have an example of that later. You do that by putting a colon after the name of the key inside of the object, and then the name of the local variable, and I'll show you an example of that later. So that's a convenient shorthand, and if you're writing in TypeScript, you're going to see a lot of that. And then the same trick can be done with arrays, but in the case of arrays, it's by position. So because arrays don't have a key or a property name that actually pulls it in, so when you're dealing with arrays, it's by position. So I'm not really showing the premier example here. Instead, I'm showing a trick you can do as a consequence of this destructuring capability. So you might know the typical computer science question of needing to swap variables. If you need to swap 2 variables, you usually need a third temporary variable in order to hold on to one of them, because you can't just say swap. So here we're saying let temp equal the value of A so that we can assign A the value of B before then taking what was originally the value of A and putting it into B. And this is swapping the values of A and B. And we can see if we console log it out, A and B now, instead of being 1, 2, they are 2 and 1. So that's a swap, a typical swap in ES5. Now, one of the cool things you can do, now I've thrown C into the mix, but you can just imagine that C isn't there as well. You can actually swap the values of two variables without a third temporary variable. Because the way destructuring works with arrays is the first value, once again, you have this weird syntax on the left hand of an assignment. Instead of, you don't normally see square brackets on the left hand of an assignment. So now we've added that syntax. So the first element in this syntax, what we're saying is let B take on the value of the first element of the array on the right side. Once again, it's done by position, as was asked earlier. And let A take on the value of the second item inside the array on the right side. Now, I've thrown C in here just to explain what would happen. C will take on the value of the third element of the array on the right side. However, there is no third element of the array on the right side. So C would be undefined. So this is a trick to swap A and B. I just threw C in there to show you that it would be undefined because there is no third element there. Any questions on that before I move on? We're going to talk a little bit more about array destructuring. So I'm not even going to point out what's on the left here. This is actually the transpiled code, I think transpiled by Babel, of what I'm going to now demo on the right. So this is a more advanced example of array destructuring, also using default values. So we're using both default values and array destructuring. So I've created an array that has two elements, the strings 1 and 2. And that's my array, which I have here on the right-hand side of an assignment. The left-hand side of the assignment, however, is these 4 lines. So I say first is going to be equal to alpha, or if that's the default value. First, actually, because it's an array destructure, we'll initially try to find the first element of the array on the right side. The first element of the array on the right side is 1. But if it was undefined, it would take on the value of alpha. Second, we'll take on the second value of the array on the right side. But if it's not available, it'll take on the value of beta. Third, we'll take on the third element of the array on the right side. And if it's not available, it'll take on the value of gamma. And then fourth, we'll take on the fourth value of the array on the right side. And if it's not available, it will remain undefined because I haven't given a default value. So I have sort of a bunch of examples here that allow you to see that first, we'll take on the value of 1. Second, we'll take on the value of 2. And then third, we'll take on the default value of gamma. And fourth, will remain undefined. And so this gives you a clear understanding, hopefully, of how the array destructuring works. What you see here on the left is actually the transpiled code into ES5, explaining how under the hood it would work if it was running in ES5. Like I said, I'm not going to go over that. It's pretty easy to understand just looking at the ES6. But it is able to be transpiled into so that older browsers could still run this code. So parameter context matching is kind of like destructuring, but in the argument list. So now if we, so here's a classic ES5 version. We pass an array that has a Boolean value and a string as the 0th and 1th elements of the array. Notice I don't say first and second. I do that on purpose because arrays start from 0. And sometimes when I say the first or the second, and then people start to get confused. So I talk about the 0th and the 1th elements of the array. So here we're saying the 0th element of the array will be A. So A will be equal to true. And the 1th element of the array will be the string 2 will be B. So if we console log out A and B, we get true and 2. And that works great. So now let's take a look at how you can do that in ES6. Once again, everything in ES6 is TypeScript. So here we're saying we're being passed an array, and I'm instantly saying whatever's in that array, A will take on the 0th element, B will take on the 1th element. And anything else in that array will be ignored. So the 3 and the 4 will actually not be available to me very easily. There are some tricks to get access to the values 3 and 4, but the point is I don't really care about the array as a whole. I destructured it right away using parameter context matching to get back the A and the B, which is what I really cared about. And so that's a trick you can do to just say, oh, I'm being passed an array, but I need the first element to be A and the second element to be B from that array. And then if you're passed a second element, like 1 here, that will get passed on as well. So I'm just showing C as an example to show that you can continue to pass other arguments. And then here I am console logging out A, B, and C. And we see the same true and 2 coming out and the addition of the third variable C as well. Okay, so parameter context matching works not just with arrays. It also works with objects the same way that destructuring works with objects. It's pretty much the same syntax. It's just thrown into the argument list. So here, normally you get passed an argument. In my case, an object. And the object here's the object, literal, where f name is John and L name is Doe. So I'm passing this object, obj, and so then I say f is going to be equal to object.fname, L is going to be to object.lname. So f will be John and L will be Doe. And I console log out f and L and I get John Doe. So here I'm destructuring using the variable names, the property names that are inside the object. So f name is the property name inside the object that's equal to John, and L name is the property name or the key into the object that has the value Doe. So here I can console log out, yeah, there goes my AAA battery again. Anyone? No? Bueller? Okay, so I console log out f name and L name, and I get back John Doe over here. So, and just to show you what it's like to rename those local variables, notice on the left I use f and L, and on the right I have to remain with f name and L name. Well, here's the exact same example, except I was able to rename the variable f name to f, and I was able to rename the variable L name to L so that I could do the same console log f and L as I did on the left side. So I am able to rename the variables as I'm pulling them out of an object, whether I'm doing it as destructuring or parameter context matching, both of which have similar syntax in different positions. One's on the left-hand side of an assignment for destructuring, the other's in the argument list for parameter context matching. Another example here of a new feature that's been added to JavaScript for ES6 and, of course, TypeScript is the spread operator. The spread operator allows you to take an array and turn it into a number of arguments that get passed to a function. So if I have an array of variables or parameters that I wish to pass to a function and split them out as in order, the spread operator will do that. So the example I use is math.max. And I usually actually give this example live coded. So let me see if I can do that here. I'm going to clear this console. And so live coding, if I have an array equal to, let's say, 0, 1, 2, 3. So math.max, if I pass it a number of values, 0, 1, 2, 3, it will take all of the parameters or arguments that's passed and give me back the maximum value. That works great. But I also have this array with the same values. So if I say math.max of array, you would hope that it would be able to look into the array and give me back the maximum value. But no, it treats the array as though it should be a number. It's not a number, and it actually returns the value, not a number. But with the spread operator, I'm actually able to take all of the values inside of the array and turn them into parameters that are passed to math.max. So it'll actually take those values from the array and turn them into individual parameters, and therefore math.max will continue to work. And in fact, if I had a second array equal to, I don't know, 5, 10, 20, 1, something like that, I can actually then spread that out as well. Say math.max, once again, if I do array 2, it's not a number, but if I do math.max, I can actually pass both array, the original array, as well as array 2, and it'll give me back the maximum value of both arrays, which is 20. So it spread them out for me. So that's a really useful feature. It's also similar to the REST operator, which I don't think I go into much detail on here. But the REST operator allows you to say, hey, if I have a function and you're passing me a number of arguments, I could say, well, the first 2 arguments should be A and B, and then put the rest into an array, and it used the inverse syntax where I'm sorry, I don't have an example, so I'm talking without being able to I should probably, I'll try and put up an example of the REST operator later. I need visuals always help. Okay, there's some new functions that are available off of the object inside of ES6 in TypeScript. You can, there's a static function called keys that given any object will return the keys of that object. There's a static function called entries that given any object will give you paired arrays of the key value pairs inside of that object. And there's a static function called values that given any object will give you back the values of that object. So here we have object with A is 1, B is 2, and C is 3. If I ask just for the keys, I get A, B, C. If I ask just for the values, I get 1, 2, 3. And if I ask for the entries, I get A, 1 as an array, B, 2 as an array, and C, 3 as an array, where I get these sort of tuples put together that are paired. So this is actually new. These are new functions that are available in ES6 that weren't previously available, and they allow you to do a little bit more introspection into your objects in JavaScript than you could do previously. We also have this concept of computed property names, which actually has existed for a while. There's this syntax, which I think a good example would do. Let's create an object. I'm going to clear my screen. Let's say I'm going to create an object. Let's say it's I don't know, name is Daniel, and I don't know, city is New York, NYC. Let's say something like that. What's that? I'm missing a quote? Oh, thank you very much. Appreciate that before I hit enter. Okay, so there's my object, right? Let me just get back to what I was about to... Oh, right. So it is possible not only to talk about object.name, that's very common, but most people who program in JavaScript know you can also ask for object.name as a string and get back that same value. And you can also assign name as like say that my property is actually equal to name, and so I can ask for object of properties where I've kind of got an extra level of indirection, and I can get back Daniel that way as well. So that's been around for a very long time. So I might even have a function that returns a string and then say that's the key that I want into my object. But if we come back here, one of the weird things that was about object declarations in old ES5 was it wasn't always possible to define everything inside of the object literal declaration directly. So for instance here, if I wanted to add a property baz with some computed suffix, I would have to do that after I declared the initial object. I could then say, oh, compute what the suffix is, add it to baz, make that the key into my object, and then here's the value I'm assigning. Now in ES6, we are able to do that directly inside of the object. So we're able to use this new syntax where you have a square bracket inside your object declaration, and we say baz plus suffix. And the advantage of that is that you are able to put the full declaration of your object in the initial declaration there. And this allows you to group your code in a way that at least when looking at it, you can find all your initial object declarations. The only problem with JavaScript in general is it's completely dynamic. And so just to go back to my example here, I have this object, right? And I'm going to just type it out again. There's nothing to stop me from adding a dog to this later on and saying dog equals, let's say, Brandy. And now my object not only has name and city, but also has a dog. And that's the nature of JavaScript. At any point in time in the future, you could just go and stuff another property into any object. Only TypeScript actually allows you to declare type and say, no, wait, there is no possibility. This type of object can't have a dog. And that's one of the things you get from TypeScript that you don't get from JavaScript. So that is one of the things that we're going to be talking about a little bit later as I get towards the TypeScript specific nature. One of the other things that you can do now is declare functions. So here, the old world, you'd have to say foo is my property, and then here's the function, because remember, functions can be attached to variables. Now we have the shorthand. You can actually put the function declaration right there. And you just still have to put the comma at the end, but you might notice this starts to look a lot more like a class. The only difference is now we have a comma still here. And then finally, I'm going to mention generator functions. Generator functions are used in ES6 and TypeScript to create iterators. And so iterators have been around in other programming languages for a while, but now JavaScript has generator, under the hood is using generator functions to create iterators. So I can ask for all of the values in an array without necessarily needing to use an index or counter variable like I. So whereas before, in my very first example, I said for I equals 0, and then you usually say, as long as I is less than the length of my array, and then you use I as an index into your array. Nowadays, and we're going to be talking about this later, you can just say, give me all of the values in this array without using an index. I don't care what the index is, I just need to know what all the values are. And so generator functions will enable that. We'll talk a little bit more about generator functions on a future slide. But the reason why I point out this looks a lot more like a class is because the next slide I finally show you what a class is. So class is a keyword that's been in most object-oriented programming languages. And although JavaScript, it was capable to program in an object-oriented style, the syntax in ES5 and earlier was ugly as sin. I say this, I was a Java developer that moved to JavaScript trying to remain true to my object-oriented roots, and it was really hard. You had to usually put things on the prototype, as we do here. So if I had a function that I wanted to attach to my person type here, I had to take the person type's prototype and put the function there. So declare that all instances of person type, like Nicholas here, this person variable who's going to have the name Nicholas, I had to put the sayName function so that later on I could say person.sayName. I had to put the sayName function on the prototype. And people who aren't coming from, aren't knowledgeable of JavaScript's prototype nature is going to look at that and go, that's weird. Why am I doing this? So finally, ES6 created this class keyword. And the class keyword allows us to program in JavaScript like one would in Java or C# or other object-oriented style languages. So now, the only thing to note is there's only a single constructor in a JavaScript class. And there's a reason for this. Other programming languages might overload the constructor, where there might be two constructors with different parameter lists, different signatures they call it. But in JavaScript, you can pass multiple parameters or argument lists to the same function. So even if a function takes no arguments, you could pass it 100 arguments. Or if a function in JavaScript takes 100 arguments, you could pass it none, and it won't complain. So as a consequence, you can only have a single constructor, and then you have to have that constructor be prepared to accept 0, 1, or many parameters being passed into it, as opposed to having multiple versions of the constructor with different signatures. So here's our single, one and only constructor on our person class, takes in the value of name, and says this.name equals name. So the instance variable person on the right is going to be equal to new person class taking on the value of Nicholas. So this.name will be equal to Nicholas in that particular instance. Now it gets a lot prettier. My sayName function is defined right inside of my class, not as a separate level as a prototype. So right inside my class, I'm able to put my sayName, which is the way it's done in all the other programming languages. And then I can say, later on, I say person.sayName, and I get Nicholas over here just as I would on the left. So this is no longer the popular style. This is now much easier and much easier to comprehend, especially when coming from another programming language. So now let's just talk about the peculiarities here. Yes?
Does that support inheritance?
That's the next slide.
Okay.
Okay. So let's talk about the peculiarities here. So person, if I say is it an instance of person class, yes, it's true. And on the left, person is an instance of person type, that's true. That makes perfect sense. Also, I can ask, is person an instance of object? Now remember, all classes inherit from object implicitly, so they are both objects. Person is an object in both cases. Now here's the last line is the strange one. We ask, what type of is person class? Now, if class was a type, you would think that the type of person class would be a class. But in fact, there is no class type in ES6 or TypeScript. Instead, it says person class is a function. And that has to give one pause and say, well, how is that? That person class is quite clearly defined as a class there. Why is it a function? And the reason why is we find out, and I'm telling you now, we find out that everything to do with how class is defined in ES6 is nothing more than syntactic sugar on top of what we used to do in ES5. So actually this, when transpiled, turns into code that looks like this. It's actually under the hood, it's the same thing, and that's why we're able to use classes and transpile them to older ES5, because really under the hood we're just using functions. And that's the way we used to do it. It just looks a lot nicer when we actually program. It still works in the older JavaScript interpreters though. Inheritance. So inheritance is also available inside of ES6. And the way it used to be done was you used to have to use the prototype again, and it's ugly, and I'm not even going to bother going over the prototype version of inheritance. But let's take a look at the syntax in ES6 for inheritance. We have our person class, which has a constructor that assigns a name. And we didn't give it any other capabilities. The only thing a person class does in this case is store a name variable. And then I created a person hello class that extends person. Now here, I am explicitly giving it a constructor. I do not need to. I did this as a demo just to show that, well, if you're going to call person hello's constructor, if you create a constructor, you must pass it to the superclass's constructor. So super here is actually an explicit call to the constructor of the superclass, which is person class. If I left this off, there would be an implicit call to the superclass. So I could actually erase the constructor from person hello, and this would all still work. But the point here is that person hello adds a hello function. That hello function has been added, and now anytime you instantiate a person hello, you can actually call the hello function, and it will still remember the John Doe. John Doe, which was stored in the person class from the functionality of the person class, which this extends. So I can say hello, this.name, and that this.name was stored in the superclass. Any questions on that? Once again, this is a very simple example of inheritance, but it still shows that we have the extends keyword that allows us to do inheritance. The extends keyword is very typical. It's used in Java, C#, and the like. Question?
But I read that it's better to use prototype of inheritance.
Well, this, once again, under the hood, this is using prototype inheritance. This is essential. Once again, this will transpile to what we see on the left. This is much easier to read, and under the hood, you're actually using prototype. When you say it, so you heard that it was better to use prototype inheritance?
Yeah, rather than the classic inheritance that we know from C# or Java.
Gotcha. Well, I mean, I think you are forced to use the classic prototype inheritance under the hood at least, because we don't have this type of inheritance that's available from those other languages. But now we have the keywords that mimic it. So now you can program in the style of C# and Java, and still under the hood you're actually using prototypes. So once again, this is syntactic sugar for the prototype part on the left. So if you're coming from one of those other programming languages, it's much easier to understand.
Can you do anything before the super call of the person hello class?
Can you do it before as opposed to after? In some languages, super is supposed to be the first call. I don't remember if it has to be the first or it can, but it has to be in there. It could not be in there at all, right? But that would be a little, right? You could basically have no super call and just say, hey, when I inherit, I totally take over what I do here. That's allowed as well without a super call. But then you'll have all sorts, things will break if you don't have any super call.
Most of them will say you have to have a super call.
You have to have I know TS-lint would complain, but I don't know if the JavaScript remember there's no compiler, so it would have to be an error at runtime. There's no compilation with ES6 per se, so it would have to be a runtime error. So that's the question is, would you get an error at runtime? Right. That's the weird thing, the JavaScript is very forgiving, almost too forgiving, and that's another advantage of using TypeScript or even Babel, is the fact that you're pre-processing it through a compiler that's looking for errors like that. So that in the case of in the TypeScript compiler, definitely would find it. I just don't know what would happen if you typed it straight into the browser. So let's talk about import and export. Checking my time again, got 25 minutes, right? Good. So import and export, once again, you need to use Webpack in order to achieve import and export or System.js. But the old school way of doing things, let's say in Node, they use this common JS file format where they'd use a require keyword to bring in an external file. So you might have a lib file here which has a function foo, and then you'd have this exports object, and you would attach variables to that exports object, and that would allow you to pull them in later. That same object that's here, I could pull in here, and this represents the fact I'm in another file now. So in another file, I can require the lib file that's above and get my foo back that's been attached there. So that's the common JS file format. So they decided to forego trying to duplicate the common JS file format, instead go with the import keyword. So now, using import, there's two ways you can import something. First of all, we now have an export keyword. So given a file, lib file in ES6, we can have a function foo, and we can have another function which we've labeled as export in front of it. And then we finally have this export the default foo. So we're exporting both of these functions, but in two different ways. One, we're just tagging the function as being exported. The other, we're saying this function is the default export for this file. So the default export, you can just say import foo. I could actually say import bar there, or import some other variable name. Whatever variable name I specify there is going to be assigned the default export from lib file. So it doesn't matter that I call it the same name. I could call it something else. However, for another, I'm using the destructuring style of syntax. I actually have to use the variable name that's in the other file. I'm destructuring the whole file, pulling out something that's been exported, and assigning it the variable another. So in this case, I've both been able to get access to the foo function that returns true and another function that returns false. So that's my imports from another file in ES6 and TypeScript. Symbols, I'm not going to go into symbols too much. They're a new feature of ES6. They allow you to create a type of variable that can't be reproduced. So if I create a symbol with the label foo, it would be unique to any future symbol created with the label foo. So although internally I can see if I output it, it'll actually say console log foo, and it'll say, oh, I'm a symbol foo. It's a unique index. And so it can be used as a hash key or some such, and then if you ever lose access to that variable, you actually lose access to the index into your object or the index into your hash. Once again, it's not used too much. It's kind of a security feature in JavaScript. I'll let you look into that further on your own. And then there's symbol coercion. I'm going to skip over that. And let's talk about sets. Sets I find a little bit more interesting. You can do set arithmetic in JavaScript now with a built-in type for sets. So I can, the unique thing about sets is that any value in a set can only exist in it once. So unlike an array that has positions, where I could say my array is 1, 1, 1, 2, 3, and I could have 3 ones in my array, you can't do that in a set. In a set, if you add a 1 to a set, it's in the set. You can't add it again. It doesn't make the set any bigger. So I think here I do this little trick with objects. So this is not as explicit of sets as you might think. This more tells you about the literal objects and how they create a new object each and every time. So let me go over this example, which talks about how, so I have object 1 equaling a literal object and object 2 equaling a literal object. So my point here is object 1 and object 2 are two distinct objects. When I use this literal object declaration, I am creating, instantiating an object. Each of those are two different objects. They are not equivalent. So if I add object 1 to my set, my size of my set becomes 1. If I add object 2 to my set, it is a different object, and therefore the size of my set becomes 2. Once again, you can't add the same item to a set multiple times. So the fact that my size becomes 2 means I have two distinct objects. And if I add a literal object again, my size becomes 3, because that itself is also unique, not the same object as those two up there. So if I ask foo, does foo has object 1? That's true. Does foo has object 2? But if I ask foo has a literal object, that is a fourth literal object I just created there on the spot. That one is not inside of the set. So it's going to say false. So this is more about object creation than it is about sets. But I will go back to my example here, and let's take a look at my array I think I have here. So I have this array, right? Let's actually create a new array which has some multiple values in it. 1, 1, 1, 2, 3 was the example I gave. So if I create a new set from that array, notice the set size it got rid of all the duplicates because sets can't hold multiple versions of the same value. So one quick way to find all unique values in an array is to throw a set onto it and ask the set for its size. I didn't actually assign it to a variable, so I can't ask for its size. I think I can do .size here. There we go, size 3. Okay, cool. So I got about 15 minutes. I'll try to wrap up with some more TypeScript towards the end. Let's talk about iterators really quick. So I mentioned there was a way to get all the values out of an array. So I can use the let v of. This new of keyword in my for loops will allow me to eliminate the need for me to have an index value into my array. So now I just get the values back. So I get values, all the values, and I console log them out. I get the values 1, 2, 3, 4. That works in a set or in an array. I don't need to bother. And then, of course, keys, values, and entries are available to me as well. Maps are also available inside of ES6 and TypeScript. We can map a key to a value, and this is how it's visually represented. Foo maps to bar. I can say, hey, map.getFoo, and I'll get back bar. I can have a map has foo, which is a key, and it'll say true. I can delete the key. That'll remove that entry. I can have it has foo, and it'll say false now. And I can clear a map. So maps are key value pairs. They're kind of more optimized than just using an object as a key value map. And they also use a different syntax that's much more familiar to people who use maps. Libraries. So maps can be used as like an internal hash map inside of JavaScript. Once again, I talk about the of keyword that works on arrays. And then here's a little weirdness. The in keyword that has existed since ES5. So I'm asking, is 4 in foo, and I get back the value true. Then I ask if 5 is in foo, and I get back the value false, and I says why. Because the in keyword actually looks for property or key values in an object. Arrays are object. So if you looked at all the entries in the array object, you'd find that the entries were 0th element is the value 1, the 1th element is the value 2, the 2th element is the value 3, the 3rd element is the value 4, and the 4th element is the value 5. There is no 5th value. That's the reason why 5 is not in foo, because when you ask if something is in foo, you're asking if its property name is in there, not if its value is in there. So this is kind of a trick. It's a good trick for like a JavaScript quiz or something. So the in is an old ES5 capability to look for property names inside of an object, not for values inside of an array. Generators, quickly. So here's a generator function, and just to show you how they're used to implement iterators. So here I can actually use of on a generator function. So here's my generator function. It takes an initial value, and it says as long as that value is less than 5, it will yield, new keyword for generators, yield the value. So when I first call on this, I pass in 0, and it yields the value of 0, and I console log out 0. But as I re-enter my for loop, it re-enters exactly where I left off. So it re-enters the generator function, immediately increments the value. So it re-enters right there, which is weird. That's not the way any other old JavaScript functions would work. So once we've incremented the value to 1, we check to see if the value is less than 5. It's not, so we will console log out 1. We'll once again increment 2, 3, 4. When it's 4, we will, so we're incrementing value to 4. We check to see if 4 is less than 5. We yield 4. We console log out 4. And then we re-enter, we increment value to 5. We check to see if value is less than 5. It is no longer less than 5, and we exit our for loop. So you can see you can use generator functions inside of for loops. That is how the iterator functions are implemented under the hood with these generator functions and the new yield keyword. Generator functions can be used for other purposes besides iterators. For instance, you could create a generator function that says compute the next prime. And the advantage is the generator function itself has its own scope, so it can keep track of the old numbers it's already calculated and continue on from where it left off. So it has scope. People who are familiar with Clojure might be familiar with why the function can maintain its own scope. ES6 has number formatting, international number formatting. So here's Arabic Egypt formatting of these numbers. So that's available in ES6 that was not in ES5, also available TypeScript. We also have currency formatting. Here's German, Deutschland formatting in euros. And we have collation, so we can sort a umlaut against Z based on the German way to compare them or the Swedish way to compare them. Hey, that's pretty appropriate for where we are today. And in Sweden, the A with the umlaut actually sorts after the Z. I guess you could ask somebody downstairs if that's true. I'm sure somebody here knows. And that gets us more into our TypeScript. So let's focus more on the specifics of TypeScript over ES6 today. So we have Boolean values, and we can actually say a variable in TypeScript must remain a Boolean. So that's where we're declaring type. We use a colon after our variable name, and we say this is a Boolean value, and we assign it false. The advantage of this is we are no longer able to assign anything but a Boolean value to the variable is done. That is the whole point of TypeScript. It has type checking. And it'll do this during the TypeScript compilation phase. Make sure we don't accidentally attempt to assign a variable to is done that's not, in fact, a Boolean value. We also have the numbers that we mentioned earlier, which can be either decimals, they can be hexadecimals, they can be binary, and there's even octal, which I barely ever use, base 8. And all of these are the literal formats for those style types, and a number can hold on to any of these types. Strings have to be enclosed in quotes. If you're using Angular, Angular's TS-lint standard will require you to use single quotes, they say, but actually double quotes are legal in the language, but the linting tools usually want you to use single quotes. And then array, here we say let list be an array of numbers. So here's one syntax for declaring an array of numbers. And then there's a second, you can also say it's an array of numbers. So both of these are actually equivalents for declarations of an array of numbers. So both of those are valid in TypeScript. And I have a link here to all the basic types in TypeScript. We also have the ability to declare tuples. So here we say X is an array of type string, comma, number. So we know the first element has to be a string and the second element has to be a number. So saying X equals hello, comma, 10 is legal, but saying X equals 10, comma, hello will not be legal because we declared the order of the values inside of that tuple initially. We also have enums, which I like a lot. They give you the ability to create indexes it's almost like constants of a certain type. So here we have color.green. You also have the ability to give them decimal values. They will start off at 0 if you don't specify, or you can specify red equals 1 and it'll start counting from 1, green will be 2, blue will be 3. Or you could actually explicitly give them, red equals 1, green equals 3, blue equals 5. You're allowed to give them explicit numbers as well. And then you can refer to color.green. Under the hood, it's a decimal value, but allows you to make sure that you're only assigning the proper type to C. So C is going to either be green, red, or blue. We also, in TypeScript 2.4, we've added string enums, and I actually have an example of using string enums that's available on GitHub. That project was assigned by Minds.com. They're using Angular as their front end. And it's an open source project, so you can check out their open source code at minds.com. It's available on GitHub if you want to check out their source code. And they're using TypeScript. Also here, in addition to those basic types that I've already talked about, there's any, which says, hey, I want to opt out of type checking. I don't know what type this is going to be. That's almost the old school behavior of JavaScript. So I'm able to kind of say any variable can be assigned to not sure. I start off being equal to 4, but I could later assign a string or a Boolean. I'm kind of giving up on type checking for that particular variable. Void would be the absence of a type. So if I have a particular function that won't return any type, So here I have a function that has only an alert. I can say that that function is a void return. It will never return anything. Also, null and undefined are actually, you can declare things as null and undefined, but typically they are subtypes of all other types. So you can have a number equal to null, or you can have a number equal to undefined. Once again, the default for a variable that's declared as a number or a string will be undefined until you instantiate it. So undefined is that default, just like it was in JavaScript the whole time. And never is for a function that will never return. So if we throw a new error, we know that this function should never return, and we can actually declare that it never returns. And if the static analysis of this code shows that it could possibly return, then you would get an error, because we know this method should never return because it explicitly throws an error, which should prevent it from returning. So we've got our standard type annotation that I've already brought up. And so here we have id as a number, foo as a string. And for functions, we can say the function alpha, not only does it take parameters foo that's a number and bar that's a string, but it returns a number at the end. So here we see foo is a number, bar is a string, and it returns 5, which is appropriate. But this works also for our arrow functions. So beta is also a function identical to alpha, which takes a number and a string and returns a type number, explicitly 5. So when it comes to classes, we have class person. We can declare the types of properties inside of a class. Now, this is actually something that's not allowed in ES7, although there's something that's talk of it in it's not allowed in ES6, but there's talk of allowing it in ES7. You can't actually explicitly declare a property value inside of an object in ES6, which is allowed in TypeScript. You'd have to say inside of some function or the constructor, this.name equals something. Here you're actually able to declare name, colon, string, and even instantiate it right in the initial declaration of the class. That's different in TypeScript than in ES6. We can